right on. You can do it like right in your notes if you want to kind of continue where we left off. But it's up to you. What you want to remember, I've got 3 more properties to go through. So if you want to have them all in one spot, you're going to want to leave, probably was a poll, you probably want to leave at least as much space as you used yesterday, if you want your notes to all be in order. Or if you're like, you know what, here are my first 3, and here's the practice that goes with those first 3, you do those back to back, that's cool too. Totally up to you how you organize your notes, but just know that there are 3 more properties that are coming today. So if you want to have all 6 properties all in one spot, again, it's going to take up at least as much space as it did yesterday. I'm going to need both boards. That's up to you. So you can like just say, all right, I'm just going to keep going. Write in my notes. I'm just going to do my work right now because I'm going to call it classwork 4.1. We're going to put it on Canvas as soon as we're done. And folks at home, I don't know why it's making me admit people again. It's so stupid. Folks at home, it's already on Canvas. Just go to modules or go to assignments in there, but I'll just drop it in the chat for you right now so you can jump in there. Hopefully I got it right, Joe. There it is. All right, but there is something in Canvas called Classwork 4.1, and it's 8 problems that just practice the stuff from yesterday. But it's right here. When you multiply, let's add the exponents. When you divide, let's subtract. You have exponents raised to higher exponents. Let's multiply. But I'm going to write them down up here so you can see. Where is my eraser? What's up, no? All right, but that's the idea. So I'm going to come over here. Maybe a darker marker. Here's black. All right. 1, 2, 3, 4, 5, 6, 7. All right. Here they are. Now, these are just one step, which is real nice. Write down the problem and your answer. And when you're done, don't put it on Canvas just yet, because I want to check them as a class, and then you'll kind of like check them off as you go or make corrections as you go. I'll give you some time to work on it. But it is sitting on Canvas. If you're like, I can't see that very well, or I just like to see it in front of me, like go to Canvas, go to chapter 4, either in assignments or modules, and it's the only thing sitting on. Eventually, we'll have to do that anyway, because we'll put it on Canvas, like today, in like 10 minutes. I just want to get a grade in there for you for the 4th quarter. And let's see how much you remember from yesterday. There you go. Take a little time. Try those 8. Again, don't put them on Canvas until we check them out. But take a few minutes. See what you remember from yesterday. If you got questions, ask. Nothing about this is going to be graded for correctness. So don't sweat that. Let's see if this works again. Let's see. Next. Yeah, there we go. Nice. All right, write down the question and the answer, like right after. You don't have to show steps in between. Basically, all of these should just be one step. Look back at your notes from yesterday if you need some help. Yeah. Yeah. You think I could one down with that? Properties of exponents. Sure. fast way to deal with exponents. Look at number one. You got same base, you multiply together. Okay? And they've got exponents back. Fastest way to get to just like one variable with one exponent. That's what we're going to get to. You multiply, x is a, b, whatever. Add their exponent.
One number is add exponent. So
But one times one is still one.
okay.
So the coefficient doesn't change. Right? You got x to the fifth, you got square. Yeah, you got one times one, okay, cool, still one. Yeah. Yeah. When you divide, again, you're going to get rid of the fraction. You're just going to have a single variable with a number. Now, that exponent is always going to be subtracted. You have an exponent raised to a higher exponent, like number 2. 8 in the third. Multiply those exponents. You're going to drop down one level, like one full level. Yeah.
So that one just subtraction? Yeah.
Yeah. Perfect. Yeah. You get rid of the fraction, you subtract the exponents, it's one letter, one exponent every time. Looks good. If you're done, hang out. If you're still working, take a few. No rush today. I just got the last 3 properties that we'll go through for the last, I don't know, like 20, 25 minutes. They're a little different. They're a little bit weird. And I don't know. I mean, maybe you guys that have me in Algebra 1 can tell me, did we do this? Algebra 1, we did something like this, right?
I remember it.
I just don't remember how far we went. I feel like we got like, maybe like through like the next one, or like the 4th one, or maybe the 5th one. I don't know. We'll see. We'll see how it plays out.
Was that the first one?
Yeah, but you just don't like mix the different together. You don't like combine A and A, and you don't combine B and B.
Yeah. A wave, B, X is Y.
So B would just be 5, and A would be 7.
Well, for number 5. Yeah. So yeah, put your A's together. Cool. 3 plus 4 is 7.
That'd be A 7 times B. Oh, 0. Oh, 1. That'd be 6, B 6. Okay, so that makes sense.
Yeah. Because there's one of them, right? It's there. There can't be 0 of them if it's sitting there, right? So that exponent can't be 0. It's got to be 1.
Put the little cottage.
You don't have to, like, I didn't put it here, right? Because I don't really need it. I didn't put them here or here.
Okay.
If you like to, though, go for it. The thing about putting the times is that sometimes I get lazy with it, and it kind of ends up looking like that. Because I just like go real quick, and that kind of looks like subtraction, and it is not.
So then for 7, you want me to do the same as I did for 4, but put the A's together?
A's with A's, B's with B's. You got it. Yep. Yeah, gotta have the same base if you're gonna put anything together, for sure. So, yep. So if that's B with this is a B with X. Gotta be something, isn't it?
Yeah, you give them separate.
So M4.
7. 7 is really similar to 3. Yeah. I just got A's and B's. Right? 7. This one had B. So something like 7 is to be A's with A's, B's with B's. Ask. Sure.
Okay, so I just don't know like which one was. That's fine. Yeah. You got that one.
So we're going to talk about 8. That one's a weird one. We've never had a number.
Because I feel like then you're not really solving. I don't know.
Right.
And then those are not.
But like that 2, like that's like being multiplied through like the A and B and C, right? It's like 2 times A times B times C. Like it's kind of like all in the same row. So can a number that's not an exponent change an exponent? Probably not, right? That's like too much power we're giving to that lead 2. And so the question is, okay, like what am I supposed to do with it? And we're going to talk about it. So when we subtract exponents, that whole process of division, we're getting rid of fractions. When you take that step, when you say, okay, I'm dividing, so I'm going to subtract the exponents, when you do that, the fraction's gone. So this is not right. That's right. But the only thing you got to watch out for, hold on, Dave. What's that exponent right there on top of that A that I'm writing? Yes, you got to put 2 minus. Not 2 minus 0. That A squared got to change it.
So would this one be, since it's up there, would just be a 2?
So the 2 right there, that's a 1, right? So that's A to the first.
I wasn't. A1, Abby.
All right, so take a second. Let's finish up. If you're still working, I'm gonna start putting some stuff up for you. But I want to talk these through to make sure you're good. And folks at home, let me know. Give me a shout if you need anything at all. As always, I know it's tough, but we'll do the best we can. All right, let's do it. So that's the toughest one on here because we haven't dealt with that yet. We've never dealt with having a number as part of it, so we'll definitely get there. I'm not expecting most of us to get 8 exactly right, but I bet we got most. All right, let's do it. You guys can help me out. Again, here's the goal. If we have one, some coefficient, whatever our variable is, and the next one. 5. All right, here we go. First one, what'd you get? X to the 7. Perfect. When you multiply, you add them, done. One step, 2 plus 5. No problem. Right? Number in front, just a 1, so nothing changes there. 1x, like I only want one variable of each kind once I'm done. And I do whatever the little shortcut is for the exponents. 2 plus 5, 7. Nice. Okay?
I got 8.
How'd you do that?
I just did 5 times 2.
That's all you got, right? Exponents raised to higher exponents, multiply them together. Good, right? A coefficient is just a 1, it's all good. A to the 15th, 1 letter, 1 exponent, ready to go. What about 3? 3 to the 4, nice. When we subtract exponents, the fraction disappears, and that's kind of the point. I'm trying to get to the spot, or if I can avoid fractions, I'm going to do it. And that shortcut does exactly that. I don't care what goes on there. If I can subtract those exponents, I'm getting rid of fractions. Nice.
In the future, we should play a mad game of bingo with you.
I'll be down. We might have some time at the end of this week. If we can come up with something, I'd be cool with that.
I mean, like you figure out like the equations, like 8:15.
Yeah. Bingo! That'd be kind of dope. You get like a little card out. I'll see if I can come up with something.
Or Jeopardy, man.
I'll give you like harder ones at each level. That'd be cool. Get some teams going. We should play some kind of games in here. I'd be down. All right, 4. We gotta learn it first though. What'd you get for 4? We got 3 of them being multiplied together. Doesn't change your process, right? Still a single variable and just add them up. 13 again. Lucky number. That's my lucky number. X to the 13. Beautiful. All right. 5 changes things up on us a little bit because now we've got different variables in the same problem. A to the 3rd times B to the 5th times A to the 4th times B. Okay, what do you got? 8 to the 7th for sure, because all you have to do is put the a's together, right? So 3 and 4 is 7. Okay, and then what was your b? B to the. So you got a 5 right here, but what's that? There's gotta, like, if there's a b there, it's b to the 1st. So not b to the 5th, Caden, what should we change it to? B to the 6th. Beautiful. Love it. Now, if you need to write that one, do it. If that helps to draw that little red one up there, go for it. But don't forget it. If you're not writing that, then you got to remember that that's a b to the 1st. All right, cool. 6. So we just apply them to both, right? That square gets dropped on both. Is this in alphabetical order? Is that good? Does M come before N? A, B, C, D, F, G, L, M, N. Oh, so we're good, right? Because we always want to keep it in alphabetical order. So that's good. Most of the time, they're going to do right by us and start it that way, so we don't have to think about it. But you want to make sure that you end up in alphabetical order if you can. Nice, easy. All right, 7. 7 is like 3 and 5 combined.
I got a to the power of 1 and b to the power of 3.
Do I need to put the 1 there?
You don't have to.
Looks good.
What?
Do I have to put the times in between?
What?
Do I have to put the times in between?
No.
No, we're good. Can I? Can you?
Yeah.
Hell no, don't do it. No, it looks good, right? Because again, don't forget, that's an a to the 1st right there. So we got to subtract exponents. And when we subtract, fractions are gone. All right. 8 is the one that really kind of pushes us one step further because we didn't get a chance to talk about this yesterday, and it's okay. All of those inside are all being multiplied together. Go ahead.
So, you like do the whole like math thing with 2 and the cube.
Yeah, cubed, yeah. So what do you mean?
2 cubes.
Like when we thought about this one, like when we first thought about it, like we said, okay, like m squared gets squared and n to the 3rd gets squared. Like we kind of did it individually and dealt with them separately. Same thing here. Like there's 4 things inside there. Right? There's a 2, there's an A, there's a B, there's a C, and these have powers, right? But all of them get cubes. Every single piece inside gets that power of 3 for the answer. Now, remember what we're doing. Properties of exponents. This 2 is not an exponent. Yeah, I know 3 is, of course, but like that 2 right there doesn't have an exponent attached to it, so I'm not thinking about like finding a shortcut. Like that's just 2 to the 3rd. And the issue that I see a lot is that people put 6. But that's not 2 to the 3rd. That's 2 times 3. 2 times 2 times 2. And so if you started that with the 6, fix it. Okay, and that's a very common mistake to make. So don't feel like you did something so terrible. That's a really easy mistake early on when we haven't looked at this kind of stuff to just say, oh, I'm supposed to multiply. Remember, all these shortcuts are for exponents. That 2 is just a number, right? It's just a coefficient. There's a constant sitting in front, so it just gets cubed. Everything inside gets that power. It's just that, oh, okay, a to the 6th, b to the 15th, c to the 9th. Those are all the shortcuts that I'll use to get there. But you want to have that 8 sitting up front. My guess is that almost everybody probably had the a to the 6th, b to the 15th, c to the 9th part pretty good. But maybe you had a 6 sitting up front instead of that 8. But if there's any questions about any of this stuff, now is definitely the time to ask it. Because I need to use all this knowledge to kind of keep going. So we good? All right. Put this on Canvas now. Give you some points for it. Okay. There's an assignment called Classwork 4.1. Take a picture of your work, drop it on Canvas. I can give you some points for it. I still have to grade those tests too, so I'm going to try to get those done soon.
So I don't have data credit.
Perfect. Yeah. Doesn't have to be right. I just didn't want you to forget. Just don't forget. Absolutely. If you've got these down, I think we can keep going with some confidence and kind of build off this to get to an Algebra 2 level. This right now is still kind of an Algebra 1 kind of level. Basic properties of exponents that we're going to get to with property number 4, which actually has like 2 kind of parts to it. You're going to see. I could break it up into 2, but it's the same idea. So I'm just going to put it in 1. So that's going to be kind of a bigger one. 5 is super, super simple, but it builds off that one. And 6 will be quick at the end. You'll probably be thrown off a little bit by 6. Oh, I only have 25 minutes. So number 4 is going to take me the longest. 5's quick. 6 we'll end with. We'll see how we do. But tomorrow we'll come back. I'll reteach some stuff. We'll practice it. So I'm going to switch to the other side while you guys get yourselves all canvassed up. Folks at home, do the same thing. Make sure you get yourself set, organized. I'm going to keep rolling on. And you're going to see that I'm going to set up these notes exactly the same way that I set them up yesterday. The in general kind of stuff on the left and then some examples on the right. 4 kind of, I don't know, 4's a weird one. It's a little counterintuitive. Like, it just doesn't make a whole lot of sense to deal with what we deal with number 4. So follow along the best you can. Ask lots of questions. But I'm going to set it up the same way. In general here on the left, general. I'm going to split my page, like kind of a third of the way. And then some examples. Number. So we'll have 6 of them total. This one's a bigger one. So if you're squeezing this into the bottom of a page, like less than a quarter of a page, you might want to just turn it. If you have at least like a third of the page, maybe a half, then you'll be good. I just feel like there's a lot to write down here so that you remember what to do. All right. Again, if you have Canvas issues, just email it to me. That's fine. All right. So with this one right here, I kind of alluded to it yesterday that this was coming. There's a reason why the third one is the division one and not second. Like, oh, multiplication, division, why didn't you do those back to back? It's because this third one, when we divide, we subtract one, your third property gives us property 4 and property 5. So I just like to have those back to back. And so the way that this works out, a good example, and I'm going to just use the flipped version of the one that we did yesterday for number 3, my first example. Right? First example for number 3 was x to the 5th over x to the 3rd. I'm going to flip that upside down. Oh, my bad. Hold on. I got to leave a little space. I got to leave a little space. So I'm actually going to write this over here. And I want to write one thing to the left. My bad. Like move your line over, just erase it. Because I actually am going to write something on the left, and then I'm going to do a bunch of stuff over here on the right. It's all going to be connected. Because if we're dividing, what's the shortcut? What do we do with the exponents? Subtract them, okay. And when I subtract, I get rid of the fractions. Sweet. Well, what's 3 minus 5? Negative 2. What the hell is a negative? How am I supposed to take a number and raise it to the negative second power? Does it make it negative? Like, what is going on, right? And so what I want to try to figure out is just a better version of that, because I don't like negative exponents, because in my mind, I don't know what to do. Like, put the number 3 right here. 3 to the negative second, like, what is that? In my mind, I don't know what to do. And so what I'm going to do is I'm going to work my way to the right here and see if I can come up with an answer that just makes more sense. And the way that I'm going to set it up, and I know I keep saying I don't want to do this, but I'm going to break it apart again, kind of the long way, like I did with this example in number 3, the third property. I keep saying number 3, not that one. Like I'm going to say, okay, x cubed is x times x times x, right? And x to the 5th, I got 5. Just to help us see what happens. And, I'll put the ones up top, those kind of leftover ones. So I've got 5 things on top, all being multiplied together, 5 things on the bottom. Now, if you remember what I did yesterday, I like broke the fractions apart. I made like 5 individual fractions, and we kind of looked at them separately. Remember that? I had like x over x, and x over x, and x over x, and I kind of like split everything apart. Well, I'm not going to write that out, but I am going to do that. Like, I'm just going to think about like one thing from the top and one thing from the bottom and see what happens. What is x over x? Anything, you weren't here yesterday, so anything divided by itself is 1. Really, like, these just cancel out, right? It just becomes a 1. And multiplying by 1 is going to change anything, so I can just drop it. What's x over x? It's another 1. And again, right? And what happens is when we take like one from the top, one from the bottom, one from the top, one from the bottom, we get to this point where at least we can write it as simply as we possibly can. What's left up top? 1. And what's 1 times 1? Okay. Right? What's left on bottom? What's x times x? X squared. And that must mean that this are the same. Now, before we dive too deep into dealing with that whole negative exponent territory, I want to first focus on this relationship, because they could start the problem here or here. We don't know. They could start us with a negative exponent, okay, but then we deal with that. Or they could start us with a fraction. And so that's what I want to kind of deal with separately, because we're going to get the same kind of answers. So with number 4, I don't know that I need all of this space, but so you don't have to put 2 bullets yet, but eventually I'm going to get to 2 different ideas. Like, what do I do with fractions? Well, I already know what to do with fractions, but now we got this whole thing, like, you know, I was supposed to subtract exponents and get rid of fractions. But sometimes I start with a fraction and I end with one. And that's okay. I don't want negative exponents. To me, that makes no sense. But put a 3 right here. Oh, okay, 1 over 3 squared, 1 over 9. Okay, cool, I'm done. And I get what that means. But 3 to the negative second just doesn't make any sense. So let's focus first on fractions. So what I want to kind of do is expand on these ideas with 3 and with 7 right here using this example. And now, it still works. When you divide, subtract exponents. Absolutely. 7 minus 3, 4. 2 minus 1, 5 minus 2. All good. But when you end up getting a negative answer, it's like you're like literally, like we went backwards. Now I got to do all this work to get back. And I want to help you avoid all that work. Now, I've been teaching this class since the beginning of me teaching. So 10 years I've been teaching this class. And I figured out a way that I think most people can kind of get behind when it comes to dealing with fractions. If we have fractions, right? And I don't care if it's a simpler one like this, where you've got, you know, the bigger number on top, because then we're good. Or if you have the bigger number on bottom, either way this works. And so this mindset has worked for, at this point, yeah, like at least 1,000 Algebra 2 students. So hopefully this works for you. There's a mindset in dealing with fractions that I found that works really well. And what I think you need to do is ask yourself 2 questions when a problem looks like that, or 3, or 7, whatever. Okay? Because I know what I want to end up with. I want 1 variable and 1 exponent for whatever I got. If I end up with fractions, fine. But I just want it as simple as I can. I just don't like negative exponents. So here's your first question. Where do I have more? Like, where do I have more x's? And there's really only 2 possibilities. I have more on top, or I have more on the bottom. If you can answer that question, where do I have more? Then we're off to a good start. So take a look. X to the third over x to the fifth. Where do you have more x's? Top or bottom? Bottom. That is where that base is going to end up. That, I could say like that. That is where the base goes. That is where the base ends up. On top or on bottom. Gotta be, guaranteed. And if you know where you have more of them, then you should be able to answer this question. How many more do you have? This is where the base goes, and whatever you want to say. No math teacher. That's where the base is. Okay. Second question, how many more? So look at that one. X to the third over x to the fifth. Where do I have more? On bottom. How many more? 2. That's your exponent. Now, back here, sure, okay, where do I have more? On top. How many more? 4 of them. So it's like it's b to the fourth over something. It's like, I gotta put something. What's left? If I got rid of everything from the top or from the bottom, I need something left behind. What is it? It's this number right there. It's the coefficient. Whatever's left. No, nailed it. Perfect, right? Because this is b to the fourth over 1, right? But it's that one right there. Okay? That's the exponent. The coefficient is left behind. Bring it with me. Now, most of the time, right, if you have more on top than on bottom, you just get rid of fractions anyway, so you don't have to worry about it. But if this was like a 2, okay, b to the fourth over 2, you got to bring that coefficient with you. Right? If this is 7 over 5, right, if you got numbers sitting out in front, all right, cool. I'm just going to bring the coefficient with me. I'm just going to leave them wherever they were. Right? 7 goes on top, 5 goes on bottom. Those aren't exponents. They're just numbers. We just bring them with us. And so that has helped me out a lot, kind of, because now I'm done. There it is. Yeah, I end up with a fraction, fine, but hey, at least it's not x to the negative second, which doesn't mean anything to me. And we can apply that as much or as little as we think we need to, given some problem. So here, let's do a different one. A to the third, b to the sixth over a to the seventh, b to the fourth. Anytime I have fractions, yeah, subtract exponents fine and get rid of fractions, but if you've got bigger numbers on bottom, you're going to end up with negative numbers, and you got more work to do. I want to do this in one shot. So here's what I do. I give myself a space to work. Now, I might not end up with a fraction. Fine, I'll put it over 1, or I'll just erase the fraction. I'm using a pencil anyway. But I give myself a space to work. And I just go alphabetical order. A's with A's, B's with B's, C's with C's. But I don't really subtract these. I look at these A's and I say, okay, where do I have more? Top or bottom? You can say words. Okay. Bottom. That's where it ends up. How many more? Here's my exponent. Here's the done. Look at your B's. Where do you have more? Top or bottom? B to the 6th, B to the 4th. You got more B's on top. Okay, that's where it ends up. How many more? Done. I don't even need to bring a 1 with me because there's a spot on top and a spot on bottom. If you get rid of everything on top, cool, put a 1 there as a backup or whatever the coefficient is. If I end up with a 1 on the bottom, then I'll just get rid of it like this right here, right? This is over 1. No, I don't need that. It's gone. Feed the fourth. I'm working. One more. X to the 5th, y squared, z to the 9th, over x squared, y to the 8th, z to the 8th. Give yourself a space tool. You start with a fraction, you might end up with one. If you don't, fine, I'll just erase it and I'm done. But just go in alphabetical order, and if they're nice, they'll put it in alphabetical order, so just go left to right. So look at your x's first. Where do you have more? Oh. How many more? X's are done. What about your y's? How many? What about your z's? How many? Do I need it? Done. No, because you have one letter of each with one exponent. And that's always the simplest version. I want no parentheses. I just want one of each. Yeah. Okay. Now here's kind of the second part of this that gave us this whole problem in the beginning. What if we have negative exponents? I want to skip all of this craziness in between. I don't want to do any of that. I want to jump right from x to the negative second right to 1 over x. So what do you think is happening there? That we can skip everything in here. We don't have to worry about this whole top and bottom and figuring out where there's more, because if it starts as x to the negative second, maybe it came from this, or maybe it was like 4 and 6, or 7 and 9, or 1 and 3. Like I can't like make up where the problem where it came from. So like just go from here to that in one step. What happened? Do you think? Right. But like skip like none of this exists anymore. Like what I want to try to do, like you're absolutely right. We subtracted 5 from 3. Where's my error? Subtracted 5 from 3, got negative 2, and we just didn't like it. So we took a different route to get there. But what if it starts like that? Like what if the problem literally is, hey, x to the negative third?
Negative fraction for 1 under it.
That's what it is. You got to make a fraction and then flip it. Because that's what happened, right? We really were looking at this. And we never write it over 1, but look what happened. We flipped that thing upside down. The thing about negative exponents that we don't like in our minds is it just doesn't make a whole lot of sense, but it's also just not a very good looking answer either. So I always want to end up with positive exponents if I can. And what we notice about what happens from here to here is that thing got flipped upside down. Really, that negative exponent is like a clue that something was just in the wrong spot. And I'm even going to say it like that. We have negative exponents. This is a clue that the base is in the wrong spot in that fraction. Like it was up top, but it's not supposed to be there. It's supposed to be on bottom. And even the other way around. Like maybe we go top to bottom, but maybe we go bottom to top too. If you've got a negative exponent as part of a problem, what you're going to see is that it could be on top to start, or maybe it's like part of a fraction and is already on bottom. And what we have to do is make the switch. We are actually going to move it from from top to bottom or from bottom to top. That x to the negative second. Clearly, I mean, we just kind of worked our way through the problem. It just ended up on bottom. Because literally, it's like a heads up. It's this alarm bell that goes off and says, no, that x is not supposed to be up there. It's supposed to be on bottom. Or that x is not supposed to be on bottom. It's supposed to be on top. And when we make that move, at least we're getting into the right spot. But what happened to the number? -2, +2. What are we supposed to do to that exponent? Make the exponent there it is. And it's going to start negative. It's the only time I ever have to worry about making the move. So if it starts negative, I've got to make it positive. And to make that exponent positive, I just got to switch spots. And so this x to the negative third over here is really 1 over. And even something like 1 over x to the negative fifth, like that negative exponent, like alarm bells start going off, that's not in the right spot. I got to move that. I got to flip this fraction upside down, but really all I'm going to do is I'm going to move that x from the bottom of the fraction to the top. Well, now there's nothing left on bottom, so good. And now it's x to the fifth. Now, we're going to work more with those, like a lot more directly tomorrow. I just don't have time to like give you as many problems to work through that, so I'm going to wait for tomorrow. I just want to do like super quick 5 and 6, these last two properties. So I know that probably is not sunk in yet, and that's okay. I only have 15-minute classes. You have 5, 6 other classes you got to go to. I get it. So we're going to come back and we're going to work through those. But I'm going to come on to this board real quick, and I'm just going to finish up the last two so we can be good to go. What's up, man? Yeah. So we'll come back to that, I promise. Super, super quick, these last two with our last 5 minutes. That's more than enough time. And again, these two might, like the first one's easy. Second one's a little bit weird, so it might not all sink in. It's all good. No rush. All right. Number 5. Again, same setup. And with this one, I'm going to leave some space here too. Like just enough space to put one thing to the left, just kind of like I did with the x to the negative second. So I'll leave a little space. X to the third over x to the third. Again, I told you, man, like all of these go back to that third one with division. But if we're going back to like yesterday, and I just want to get rid of fractions, what do you do with the exponents when we divide? Okay, so what's 3 minus 3? 0. Okay. Now, 3 over 3, 5 over 5, 10 over 10, like whatever these are, if they're the same and you subtract them, you're just going to get 0. Yeah, but, well, it might start like this. Remember, it might start like this, right? Or it could start like this. But either way, now we go to the right. What's anything divided by itself as long as it's not 0? Property number 5, x to the 0. Really, anything divided by itself is 1. But what's going to happen is you might just have like some stuff to the 0 power. Are there any variables left at the right side? Gone. Everything is gone. It's just a 1. It's really the only one that's kind of weird like that, where you like, I start with an x and I don't have any when I'm done. It's because I just divide them away. That, just like x over x and x over x and x over x, all of those all ended up just being 1. Okay? So there we go. I told you fifth one's easy. X to the 0 is 1. That's it. Show as many examples as you want. X to the 5th over x to the 5th. Oh, that's still x to the 0 and anything divided by itself. All right. This one's funny. And we'll end with this one. We might have a couple minutes at the end. Okay. So think about where we're at so far. We've dealt with any letter we want, doesn't matter. And the exponents have been like nice positive numbers, 1, 2, 3, 4, 5, 6, whatever. Now we've dealt with some negatives, -2, -3, -5. Now we've got 0, so that's all good. What numbers am I missing up in the exponent? We've had positive whole numbers, negative whole numbers, and 0.
Decimal?
And
Fraction.
yeah, that's what's left. Now, every decimal, that's a tough thing to say. I'm just going to do fractions. Let's just say that. They're a lot easier to deal with. Now, if you have a decimal, I would just change to a fraction. Now, I'm not going to deal with like weird, like the square root of, like x to the square root of 7 or something weird like that. Only rational numbers. But what we've got, I know I'm going to start on the in general side. You could have a variable, I'm just going to use x, that's raised to a power, and that power is a fraction. There are 2 parts to that. Like, for example, x to the 2/3. The 2 and the 3, 2 different things. That's why they're in different spots. And just like with negative exponents, we're not going to leave them like that. With exponents that are fractions, so rational exponents, we're not going to leave them like that. But here's the rule. The number on top is the power. Like, and leave a little space here. It's x squared. And for that example. The number on top is your power. The number on the bottom is your root. So that 2 up here, okay, cool, x squared, got it, nice. But I got to take that 2 and divide it by 3 in the exponent. What that means is that is the like the kind of root that we've got. It goes around the outside. You've got a cube root around your x squared. Power over root. So like x to the 1/2, x to the first, and a square root. Right? Because there's a 1 right here, and when we say square root, that number that we don't bother writing, there's a 1 right here, and a 2 right there. And I'm going to stop right there. Seconds to spare, that's a good start. Woo! Good day. Thank you guys. I appreciate all your hard work. You guys are awesome. Head to 8th or head home, and I will see you tomorrow. Make sure you get that classwork submitted if you didn't get a chance to during class, and I will. Oh, you're go ahead. Go for it. I got you. Yeah. And I will see you guys tomorrow. Thank you.
Thanks, Rosie.
Thanks, guys. Appreciate you.